In this video, I wanted to talk about the composition of functions. Okay, so a really quick rule. We're going to let f and g be functions, and we can define a new function written as f composed g. Okay, and we can write this as f composed g of x, or we can just think of this as f of g of x. Okay, um, so anytime you see a little circle instead of a multiplication sign, addition sign, subtraction sign, whatever, anytime you see a little circle, this little circle here is called the composition. Okay, so this is really about as simple as it looks here. If you have f composed g of x, this is the same thing as plugging in g of x for f. Okay, so let's see this worked out in practice. Let's let q of x equal x squared plus 5, and let's let r of x equal the square root of x plus 7. Okay, so we want to find q composed with r of 2 and r composed with q of 2. So let's do q composed with r of 2. So q composed with r of 2 is equal to q of r of 2. Okay, so for whatever the value of r of 2 is going to be our input for q. Okay, so for uh, for r of 2, let's do this. So we have q of the square root of 2 plus 7. Okay, that's going to be q of the square root of 9, or q of 3. All right, so q of 3 is going to be 3 squared plus 5, or 9 plus 5, which is 14. Okay, so it's really that simple. You're just plugging in the value into this second function here. Okay, and then you're taking whatever that value is and plugging it into this function here, and this is going to be your output of these two functions. Okay, let's see it the other way. Let's do r composed with q of 2. All right, so this is going to be r of q of 2. All right, so let's see what q of 2 is. So this would be r of 2 squared plus 5. Okay, so this will be r of, looks like 4 plus 5, which is r of 9. Okay, and then which is the square root of 9 plus 7, or the square root of 16, which is 4. Okay, so these are not necessarily going to be equal to each other. You can have maybe a composition of one function going in one direction, composition in the other direction, and they're not necessarily going to equal each other. That's something that's very important to understand. So if you find one, you're not necessarily going to get the other. Sometimes you get the other, but not always. Okay, let's take a look at another example. Let's let p of x equal negative x minus 2, and let's let q of x equal x squared plus 1. And now we want to find q of p of 1 and p of q of 1. Okay, so let's do q of p of 1. So q of p of 1 is the same thing as q, again, of p of 1, written a little more explicitly. Okay, p of 1 is going to be as follows. Of q of, looks like we'll have negative 1 minus 2, which is going to be negative 1 minus 2, or just negative 3. And q of negative 3 is going to be negative 3 squared plus 1, or just 9 plus 1, which is 10. Okay, now let's try this one. Let's try p of q of 1. This will be as follows. Okay, and q of 1 is going to be, looks like 1 squared plus 1, which will be p of 2, okay, which will give us negative 2 minus 2, which is -4. Okay, so we get something quite a bit different here. Okay, so again, as you can see, these are not necessarily going to be equal to one another. Just remember, anytime you see this composition, it means you're going to take the second function as written here and plug it into the first function, and that will be your output. A quick word on the domain. The domain of the composition function is going to be all values of x that produce an output that's going to make sense for f, or it's going to make sense for your function that you're plugging it into. Okay, so that's how we can think of the domain. So it would have to make sense for the first one, and then the output would have to make sense for the second one. Okay. Now, there's another topic involving composition of functions that you're probably going to see in your homework, which is expressing a function as a composition of two functions. Okay, this has been a difficult topic for students in the past, so I figured I would go ahead and cover it a little bit here. It's not quite as hard as it may first appear, because but I think what's difficult about it is this is one of the few topics in this class that is pretty open ended, and there might be a lot of different answers that you could express this. Okay, so let's look at a couple examples. Let's let h of x equal the cube root of 6x plus 5, and we want to try and express h of x as f composed with g of x, which is equal to h of x. Okay, so here, what you could do is you could say f of x is equal to the cube root of x, and we could say g of x is equal to 6x plus 5. All right, so if we do the composition here, let's do f composed with g of x, okay, you'll get f of g of x, which is going to be, sorry, cube root, the cube root of 6x plus 5, because we'll be taking 6x plus 5, plugging it in for x here, and then, hey, look, we get our initial function h of x back, okay? So, another way we could write this would be, let's do f of x is equal to the cube root of x plus 5, okay? And we could let g of x equal 6x, right? So we'll plug 6x anywhere we see x here. So f composed g of x will give us f of g of x, or we'll get the cube root of 6x plus 5. Okay, so there's multiple different ways we can write these answers, and I believe Alex does a pretty good job of finding all of the different possibilities. So just remember that as you go into this, there might not be one explicit right answer here for each of these. This is going to take a little bit of creativity on your part trying to figure out how to find the answer here. But let's go ahead and take a look at one more just to get a little bit of practice. Let's let a of x equal 7x to the third minus 3. We want to express a of x as f composed of g of x being equal to a of x. Okay. So again, there's a couple of options we could have here. I'll do at least one. So if we wanted to do f of x is equal to x minus 3, we could do g of x is equal to 7x to the third. Okay, that's certainly a possibility, right? That would give us f composed with g of x is equal to 7x to the third minus 3, right? Which gives us back our initial function, right? So again, you can find lots of ways to do this. You could do it a different way. You could do it. You could say, let's see. Yeah. Yeah, I mean, there's lots of ways we can go about this. Like I could try to get creative and weird, but this is probably the most obvious and direct one you could choose. But yeah, try to get creative with some of these. If you get lost, if you get stuck on these, feel free to shoot me an email. I'll be happy to maybe make a video helping you with your specific situation or meet with you about it. Whatever's easiest. These can be pretty confusing if you haven't done them before, but don't overthink it. And yeah, good luck with your homework and have a good weekend.